Hello. In this short video, I'm going to introduce the Doomsday argument, which is a mathematical prediction of humanity's chances of survival. Now, this argument was first published in 1983 by Brandon Carter and rediscovered and refined by J. Richard Gott in 1993. These are both astrophysicists. I have found Gott's paper online. You can read it there. The argument is closely related to the anthropic principle, which is used by astronomers. For instance, it's one argument put forward in support of the multiverse hypothesis, the idea that this universe is only one of myriads of universes. I'm not going to talk about the multiverse hypothesis, but you can find material on the web. It's an interesting topic. So I plug some holes in this doomsday argument, as I will indicate. I think there's some problems with the original argument. So let's estimate the survival probability of the human race. The question is, what's the probability that the human race will survive another n years without major catastrophe or extinction? Now, that's not something you can know for certain, but probability is about estimating the probabilities of such events. And in fact, we can make an estimate using just some basic principles of probability theory. In particular, we'll use uniform random sampling. Now, the principle of uniform sampling says that if an individual is selected from a set A in such a way that no special characteristic or property of that individual is involved in the selection process, then any individual from A has equal probability of being selected. This is a standard principle of statistics that's used in surveys or other statistical tests all the time. For example, if you draw names from a hat, then any name has equal probability of being selected, as long as the pieces of paper that the names are written on are basically identical. Or if you draw a phone number from a phone book, as long as you choose any page randomly, or you choose the place on the page randomly, any number is equally likely to be selected. So in this case, if the individuals of A are listed in some order, the probability that the selected individual is in the first X% of the list is X over 100. So for instance, if you do have names in a hat and you list them in alphabetical order, maybe you have 1,000 names and you list them in alphabetical order, and you choose one name from the hat, then the probability that you're going to get a name that's before Abel in alphabetical order is very, very small, because the number of names in the hat in a hat that satisfy that property is very, very small. All right? And the proportion is calculated in this way. Well, so far, this is just standard statistics. Now, you are a random sample. You're a human being. You're a random human being in some sense. By virtue of the fact that you're reading or hearing this argument, you have been selected. There's no distinguishing characteristic used in this selection other than that you've been exposed to the doomsday argument. Okay, you're being exposed right now, and there's nothing to distinguish you from any other person who's been exposed to the doomsday argument. Now, in other versions of the doomsday argument, they try to argue that you are a random human being, which is not true, because there's no way that someone unfamiliar with probability theory could ever consider themselves as a random sample. There's a famous example of a survey when Roosevelt was running for president against Alfred Landon, and Reader's Digest survey predicted that Landon would win with a landslide, and in fact he lost by a landslide. And the problem was that the survey was a telephone survey, and all the people who voted for Roosevelt didn't have telephones. So you can't say that you're a random human being, because human beings who don't know probability theory could not be selected as someone who's being exposed to this argument. However, everyone who's been exposed to the doomsday argument, you are a random person. There's nothing to distinguish you from any other person who's been exposed or will be exposed to the doomsday argument. So let A be the set of all individuals, past, present, and future, who have been or will be exposed to the doomsday argument. And you are a random sample from this set. All right? So I'm just using the principle of random sampling. There's no other information used in selecting you. So let's compute the probability. Okay, since you're a random sample from A, where A is the set of all humans who have been or will be exposed to the Doomsday argument. Let's list the individuals in A in order of first exposure. So there's a time when every individual in A was first exposed to the argument. And we can list them one by one. Now you might object, sometimes 2 or 3 people might hear at the same time. That's not a significant objection. You can just list those 2 or 3 people in some random order. It doesn't matter. You can still list those people in order from first to last. Now the probability that you are in the first X% of this list is X over 100, as we said before. The probability that you are not in the first X% of the list is 1 minus X over 100. So if X is small, there's a large probability that you're not in the first X%. Now, so let's take the case, for instance, 50%. So there's actually a 50% chance that you're not in the first 50% of this list. There's a 50% chance that you're past the middle. You're past the middle. Given that this is true, and suppose, so here's a supposition, suppose that new people keep hearing about the Doomsday argument at the same rate as they have since 1983. Okay? Now you're more than the halfway point. If people keep hearing at the same rate, then they can only keep on hearing in the same way with the same state of affairs for at most 33 years, because you're already past the halfway point. And it's been 33 years from 1983 until now. So this state of affairs can only continue for at most 33 years. Now, the only way that people would stop hearing about the Doomsday argument is if scientific knowledge stops being shared. It's a published argument, and scientists share and people talk about scientific ideas. And this is one scientific idea. It's gained currency. It's been discussed in the astrophysical community. Okay, so the only way that this argument would stop being discussed is if a major catastrophe occurred to the human race. Then science would stop, scientific research, knowledge would stop. Okay? There's no other way that this argument would stop being shared. It's knowledge, and knowledge is always going to be shared. Now that means that there's a 50% chance that the human race will experience a major catastrophe within the next 33 years, because there's a 50% chance that you are past the middle point. Okay, and so the process of sharing the Doomsday argument can only last a number of 33 years. There must be something radical that happens within the next 33 years that is given that you're in the last 50%. So there's 50% chance that something radical is going to happen in the next 33 years that stops the propagation of scientific knowledge. Now, I use 50%, but there's nothing special about 50%. There's a 75% chance that you're not in the first 25%. That means there's a 75% chance that the human race will experience major catastrophe within the next 100 years. How do I get 100? That's 3 times 33. Okay, because you've got 25% have already gone, so that means there's 3 times as much time left, because 75 is 3 times 25. All right, so you can calculate these probabilities for any n just by changing the numbers. But one number we have is that there's a 50% chance that the human race will continue without major catastrophe for another 33 years. Now, there's a possible objection. I did suppose that the Doomsday argument continues to spread at the same rate. Okay, that's what I said up here. All right, I said, suppose that new people keep hearing about the Doomsday argument at the same rate. Now, what's the basis of this supposition? Things change. The population is increasing. The rate of science is increasing. And communications are improving. Mass media are improving. So we would think that people would be exposed to the argument at a faster and faster rate. And in fact, that just shows that our estimate is conservative. If the rate of exposure is increasing, then the number of Doomsday hearers should double in less than 33 years. So that situation can only last for less than 33 years. So there's a 50% chance of calamity in less than 33 years. So that even worsens the probabilities. All right, conclusion. According to the argument, our survival chances don't look too good. So what do you think? Feel free to comment on the video and please share with your friends. All right, thank you for listening.